Good evening and welcome to this Arctic sea ice update from Going South. The first one in October, and I still haven't changed the page on my calendar on my wall, but otherwise I'm pretty up to date. So this may sound a bit strange, but the fall and the winter and the spring is when the Arctic sea ice really takes off. And you shouldn't believe the hype from people who say it all ends in September. One of the reasons it takes off in the non-summer months for sea ice collapse is that you have the ever-increasing cloud cover in the Arctic because there is less and less ice every year. This cloud cover is like the sheets on your bed. It keeps the heat inside and it keeps warming the ice or protecting the ice from refreezing as it would do in the past. And yeah, this year has been quite extreme. The summer cloud cover, it's clouds in the summer as well as the rest of the year because of more open water. But in the summer, the clouds also in part shuts out the sun, so you don't have the same big warming signal in the summer because of this water vapor and cloud mechanics. Okay, but you see from this graph here that we may now launch into another insane plunge, like you see here for 2016 October. We just started going down here in late September. But first, let's just run through the basics of this chart. All of these points, like 1st of October, they consist of 1 year averages. So you have an entire year in this point, and in this point, and in this point, and in this point. It's all 365-day average values for extent in the Arctic. And what the level shows you is how low we are for sea ice extent compared to other years on the same date. And you only see in this chart the 4 very lowest years: 2012, 2017, 2016, and 2018. And as I said, these are 1 year averages, so it's not your average, your common daily sea ice graph. So when you see a graph going up, it's not because it's not melting, it's because the 1 year average is going up, or the 1 year average is going down, like for 2016 in August. And you may think that you only can see like 5 or 6 months here, but you actually see an entire year until 1st of October, like here, and the entire calendar year 2017 you can see in this one point, because that is the average or sum of the entire year. So for the calendar year you have 2016, the red graph is the lowest calendar year for sea ice extent, and until recently, or until this year, 2017 is the number 2 lowest, and 2012 is the 3rd lowest. Yeah, so whenever a graph is going down, like 2016 it does up here, it's because the 1 year average is sinking. So it means that the latest data for 2016 is lower than the same date for the year before 2016. Okay, so back to the present graph. You see we already started an autumn decline, like here. And that is because the daily extent graph for 2018 is now flatlining, while the last year was rapidly going up. And that was the same thing with the 2016, that you had you know, the minimum extent in summer, and then you had a refreeze for a few weeks, but when you came out into October, then the 2016 daily extent graph just, you know, flatlined or went up really slow compared to the other years. And that means that the 1 year average just takes a nosedive like this. And yeah, so we've seen these real big plunges for this graph. They've been appearing later and later in the year. So that you had in 2007, you had a July-August kind of event, plunge event. And in 2012 you had an August-September event. So the new thing in this part of the decade is that you have major plunges setting new all-year records starting in October, and it's also consistent with the main global warming signal happening in the autumn and winter and in the spring. So it's my guess anyway that when you have the first year with the ice-free Arctic in the summer, it will be because of the groundwork that's been done in autumn and winter and spring, because how much ice you have to melt is important, of course, to whether or not you can actually melt all that ice during the summer. Right. So what 2016, 17 and 18 have done, they're pretty much taken over the whole top 3 lowest year scene, you know, for extent and volume. And it started with 2016, which was lower than all other graphs in July of 2016. And then by mid-October, around here, it went lower than all other graphs, all other times of the year. So that was an all-time 1 year period low. And got us down to December 31st, which is all the days of the year 2016, was then the lowest on record, and replacing 2012, which used to be the record low. And for volume went lowest ever in late January, so that's just 3 months after extent did the same thing. And the entire year 2017 was lowest for a full year CS volume, and that also replaced 2012, which used to be record low for the year. And yeah, so 2016 volume was second lowest. So all of these 3 latest years have placed themselves in the top 3 lowest for either extent or volume. But because you see extent doing this already in October, you could say that, and then volume is following later on, 3 months later, we could say that an extent plunge is an early indicator of a major event happening in the Arctic. And this, of course, to do with warming of the atmosphere and the ocean. Many people say it's to do with the El Nino in 2015 and 2016, 2017 I think too. But in any case, we are pretty low, and you see it's not far down to 2016 from 2018 right now. So whatever happened in fall of 2016 gave us a new calendar year extent record in 2016 and for volume in 2017. And I think what happened in 2016 is that you had like 60 or 70 days of lowest ever daily sea ice extent from April till June, and that implies that you have a record open water area in the Arctic during those months, and it's also plenty of sunshine, so you heat up the Arctic Ocean more than you do for other years. And even though the clouds and the water vapor blocks out the sun for July, August, September, and prevents 2016 from having an all-time daily low record, what goes around comes around. So all the heat already in the ocean in 2016 came back to haunt us in October, as you see here, very dramatically. So that then it means that it just won't refreeze it the way it used to refreeze in early years. And you have kind of the same thing going on now in 2018, because the average extent in 2018 from January to October is only the second lowest, with only 2016 as lower than us. And that means that you have the second biggest area of open Arctic seawater sucking up the sun, and the ocean is a very good battery for stored heat. So that of course is something, that's heat that we take with us into the autumn and the winter, and we will have a pretty dramatic phase now, even if summer is over and the most of the days we will see extent increasing, but not as much as before. The latest day, 1st of October, was actually a decline in sea ice extent in the entire Arctic, and also a continued decline in the CAB, or Central Arctic Basin sea ice area. So you actually have a downward trend for daily sea ice area in the CAB around the North Pole still, even though we're in October. So yeah, and the sea ice area in the CAB is of course also a very good early indicator for what's going to happen on a daily and weekly basis now for sea ice extent and volume. So the forecast for the next 5 or 10 days indicate more warming in the Arctic Ocean, and in this context it means that this downward trend will go even steeper downward, maybe even overtaking 2016, going even lower than 2016. And it will be very interesting to see. I think by December 31st it's pretty clear that we will be somewhere around here, so second lowest for all year sea ice extent at least, and the excitement will be more like, can we actually go even lower than the insane 2016 graph? All right. So yeah, so the Central Arctic Basin sea ice area is an early indicator for trouble with the reef freeze. So it looks like it's gonna go down pretty fast from here through October and November, but how fast is like still unknown. And I could add that this light yellow shadow here, that's sort of the confidence interval for the prognosis for the dotted line. So that means no one, at least not I, believe that we're going to be exactly here by December 1st. So we're gonna be somewhere from here to there. That's the best guess right now. But we might also, go even lower, as I already said. So this is just as good as you can make a prediction from the data already in, because there's no weather forecast or guessing involved in doing this thing. It's just what's been happening in the data from JAXA in Tokyo already in the database. So this is just what is most likely to happen from what already happened. A projection if you want, but nothing that I or anyone else is sort of behind 100%. I'm not angry if this is not what happens. It's just one finger up in the air, guessing from what we've seen the past weeks. So this video will be followed by an archived February 2017 video where I go through the all-important process of Atlantification and pacification, the transformation of the Arctic Ocean into a regular ocean with warm water on top and the hottest air layers close to the ocean's surface through loss of classic Arctic inversion. So we see from both sides of the Arctic, from both the Atlantic side and the Pacific side, we see the warm ocean water and the salty ocean water encroaching on the Arctic Ocean, and that is sort of a one-way process, and eventually, after some years or decades, the entire Arctic Ocean is going to be like any other ocean on Earth, where you have the warmest layers of air and water closest to the surface where the sea ice used to be, in the old days. So, yeah, there will be an archived video just following this. And if you only want the raw meat, no vegetables or add-on videos from my archive, please subscribe to my sister channel, Clueless FM, on YouTube, where just the new stuff will be posted. Okay, bye.